Dear friends, today I have a question on capacitors. The question is by Elston Peter Rodrigues and it is related to a series combination of capacitors. The question reads as follows. If we connect two or more capacitors in series as such, then in that case, how does the charge accumulation occur in the region between the capacitors and why so? Since here the region between the capacitors is not directly connected to the potential difference, it is difficult to understand why each capacitor would get the same magnitude of charge accumulated on each. So basically, if you have one capacitor, if you just have one capacitor, suppose this is the capacitor and it is connected to potential difference, a battery you mean, a battery, and then we say that plus Q charge appears here and minus Q charge appears on the inner surface, of course, minus negative charge appears here. Since it is connected to battery, it is easy to understand the battery supplies the charges. Electrons from here can go directly to the battery so that there is a positive charge here, and the negative terminal can supply those electrons to come here, and that gets the negative charge. So that's okay. Now the question comes when you have more than one capacitors. So suppose you have two capacitors. So one capacitor is here, one capacitor, this is capacitor plate, this is capacitor plate, and then you have one more capacitor. So let's say this is one capacitor plate here and this is another capacitor plate here, and these are connected here. These are connected here. And then this whole thing is connected to a battery which provides the potential difference. So it is like this. It is like this. And then we say that plus Q charge appears on this plate, minus Q appears on this plate, plus Q appears on this plate, minus Q appears on this plate, and this is how the charge distribution is taken, and then you calculate the equivalent capacitance and all those things. The question is, this portion, this plate, and this connecting wire, this is isolated. This is isolated. It's not connected to battery. So why should a charge appear, minus Q charge appear here, and why should a plus Q charge appear here? What makes the charges, electrons flow between these plates as these are not connected to the battery? So that is the question. All right. Now the answer is, in a conductor or in a metal, inside, in the meat of the substance, you cannot have an electric field, a non-zero electric field. If this is a metal of any shape, if you have a metal, this whole thing is metal. And then if you look at a point which is inside this metal, inside this conductor, and suppose you have an electric field here. Okay, suppose you have an electric field here. If the electric field here, you have a lot of free electrons, the electric field will exert force on those free electrons, and then those free electrons will move opposite to the electric field and accumulate somewhere here. Alright, so you will have some negative charges appearing somewhere here and some positive charges appearing somewhere here. These will create their own electric field so that the resultant is zero. Only then the charge separation will stop. So in the case of electrostatics, where the charges are no more moving, thermal motion is different thing. So in that case, there should be no electric field inside the conductor. That's the clue. Now come to this situation. Suppose to start with, there is no charge here and no charge here. And we have connected it to the battery, and then plus Q comes here and minus Q comes here on this plate. Now look at a point somewhere here inside this plate or inside this connecting wire, a point somewhere inside this plate. Now this charge which is distributed here will create an electric field, and that electric field at this point will be in the downward direction. But this electric field cannot keep all these things in the static state, because if you have an electric field here, the charges will move, okay, opposite to this. So this charge plate which is creating an electric field here is causing the electrons to flow in this direction everywhere, here, 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 here. So everywhere this electric field of this charge plate will create the electrons to go in this direction, and therefore negative charge will come here. And correspondingly, since this is isolated, it's not connected to the battery cannot supply any charge. So if this negative charge comes here, it has to come from this plate only. And similar things you can say for this also. This minus Q is again creating a field in this direction. This minus Q is also creating field in this direction. So the electrons will flow in this direction. So the electrons will flow here, creating a minus Q charge here and a plus Q charge here. Now in this configuration, you take any point anywhere in any of the plate, here, 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 here. Remember, all these charges are on the inner surface, not on the outer surface. This charge is actually here. This plus Q is actually here. And this minus Q is actually here. Similarly here, this plus Q is actually here and minus Q is here. Now you consider any point in the connecting wire, in the plate, wherever you wish, you can take a point inside a metal, and this configuration ensures the electric field is 0 here, 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 and so on. So that is how the charges flow in between capacitors, this kind of situations.